Have you ever thought how old is our drinking water? Here in Berlin, it's actually quite young, just a few months old. It's extracted through bank filtration, directly from Spree and Havel rivers. But here in my glass, I brought some of the oldest water in Germany, almost 12,000 years old. It comes from very deep groundwater. So while you're enjoying your drink, just think about it for a moment. What does this age difference actually mean for us? It means that on one side, we are using old groundwater resources that were generated centuries ago and might not be renewable at our human timescale. But on the other side, our young waters in streams and rivers are exposed to climate extremes and to all sorts of environmental pollutants, pesticides, fertilizers, pharmaceuticals. Water is an essential resource for life on Earth. It cannot be substituted. With rising climate extremes, if we still want safe and secure water at a reasonable price, we must adapt. My name is Larisa Tarasova, and I study water resources and water hazards as part of international science team at Helmholtz. And we are overseeing one of the largest terrestrial observatories in the world. And today I will show you how we can use our observations and our science to secure water for the benefit of society, industry, and nature. So when we study water, we start with a single drop. And water drops are travelers. Once they are born in rain clouds, they are constantly on the move. They can travel very slowly through the subsurface to our rivers, but they can also rush very quickly on the surface, generating harm to us humans and our infrastructure. And as traveling changes us humans, it changes water drops too. They undergo transformation at a very molecular level that changes their isotopic composition, depending on the flow path that they take. And water drops are not only travelers, they are gatherers too. They collect information about our nature, about us humans, about our lifestyle. They can carry the minerals we enjoy, but also the pollutants that can harm us. And they can even remember every organism that they meet on their way, be it a fish or a virus, by collecting the fragments of the DNA that these organisms leave behind. And with the environmental DNA analysis, we can put not only a single water drop, but whole cities like Berlin, with all its wastewater effluents, under a genomic microscope of sorts. Think about how the development of optical microscopes helped to identify the agents of the deadly infectious diseases in the 19th century. We are now at the next innovation level. We can track the spread of waterborne diseases. We can identify early signs of epidemics and pandemics with the environmental DNA analysis. And at our terrestrial observatories at Helmholtz, we can even quantify the age of water by measuring stable water isotope ratios with laser spectrometry. And with that, we can understand where the water in our rivers comes from, how vulnerable it is to climate change and to environmental pollutants. And we can even observe our water from space. And with that, we can study its movement at large scale from distance. We can understand how water travels through our planet in real time. But what we cannot observe, we cannot observe the future. We cannot understand from observations alone when and where our water resource will turn into a hazard of floods and droughts. And these are two most devastating natural hazards in the world. The Ahrtal in 2021 alone claimed 135 priceless human lives and 40 billion euros in damages. This is 9 zeros in Germany. in 2021. The economical losses from droughts in the last 2 decades already estimated at 145 billion euros. And this is almost 1/3 of the Sondervermögen that the federal government is currently planning for the infrastructure in the next few years. With changing climate, the impacts of water hazards will increase. They will affect our life, our society, our industries. They will even threaten the development of the Schlüsseltechnologien of the future. At Helmholtz, we are building models to turn our observations and our knowledge into information for action and into information for making decisions. Decisions that can protect us, our society, our nature, and our industry from these hazards. And at Helmholtz Water Safety and Security Initiative, we are designing digital twins of water cycle. What can we do with them? We can test thousands of management scenarios to find an optimal solution. And with the 3 solution labs on urban water, water quality, and terrestrial water cycle, we creating the social infrastructure for the dialogue and for the co-design with multiple stakeholders, such as Stadtwerke Leipzig, Umweltbundesamt, and beyond. So with Helmholtz Water Initiative, we aim to provide the most innovative tools to tackle water problems together with people, to make us more resilient to climate extremes while still generating benefits for the industry and society. And finally, to secure water for my generation and for generation of your children and grandchildren. And this is truly a grand challenge that requires continuous investment, research, and dialogue. Cheers.